Welcome to Miss Perry's online physics lectures. Today's lecture will be on displacement and velocity. Displacement is very similar to, but not the same as, distance. If I were to measure my distance traveled from point A to point B, I would have to record the distance of every single step taken all around that curvy line. But if I was to measure the displacement is kind of like as the crow flies, a straight line from point A to point B. Both are represented with the same symbol, a lowercase d, and both are measured in units of meters. In order to calculate displacement, you take your initial position and your final position and take the difference between the two. And again, all of these are measured in meters. Let's try a practice problem. To get to physics class, you walk 10 meters north, 30 meters east, 20 meters south, 20 meters west, 10 meters north, and 10 meters west. Take a minute to pause your video and figure out what distance you traveled and what displacement you traveled. To calculate distance, you have to take into account every single step. So we have to add together every single portion of that problem. 10 meters plus 30 meters plus 20 meters plus 20 meters plus 10 meters plus 10 meters tells us that the total distance traveled is 100 meters. And notice we didn't have to take direction into account because distance is a scalar quantity. We only had to take into account the size or magnitude of that problem. In order to find the displacement, remember displacement is a vector quantity, so our directions must be taken into account. When we add our vectors together, we have 10 meters north plus 30 meters east. Notice how they're being added head to tail. 20 meters south, 20 meters west, 10 meters north, and 10 meters west. Overall, you can see that we ended exactly where we started. So overall, my displacement is 0 meters. Now let's talk about speed versus velocity. Speed is the rate at which something moves. Examples of speeds would be 30 miles per hour, 25 meters per second. And notice how all of those do not have directions after them because speed is a scalar quantity. Both start with s's, so no direction is necessary. However, velocity is speed in a given direction, which means we have a vector quantity here. Velocity is a vector quantity. Both begin with v's. So examples here would be 30 miles per hour east, 25 meters per second up, speeds in a given direction. And notice both are measured in meters per second. Those are our MKS units for speed and velocity. And there are two different types of velocity. There is average velocity. This is the formula that appears in your reference tables. Notice the little bar over the V. That stands for average, and velocity is measured in meters per second. And since we're talking about velocity, a vector, the D here stands for displacement, also a vector. That would be measured in meters. And T, time, is measured in seconds. Velocity equals displacement divided by time. However, sometimes we'll talk about an instantaneous velocity, and that instead of an average velocity would be an object's velocity at a specific moment in time. At that instant in time, what is the velocity? Now let's try a practice problem. A woman runs 20 meters east in 5 seconds. What was her average velocity? Please pause your video and calculate the average velocity. To calculate the average velocity, we're going to use the formula that we learned previously. Average velocity is equal to displacement over time. When I substitute my numbers into the equation, I see that average velocity is equal to 20 meters divided by 5 seconds. So my average velocity would be 4 meters per second east. Notice since velocity is a vector, I included the direction in my answer. Let's try another practice problem. A car goes from 30 meters away from a stoplight to 150 meters away in 3 seconds. What is the magnitude of the average velocity of the car? Please pause your video and calculate the magnitude of the average velocity. In order to calculate the magnitude of the average velocity, we're going to use the equation average velocity equals displacement over time. Before we substitute numbers into this equation, we first have to calculate what our displacement is. To calculate displacement, we're going to take final position minus initial position. The difference in those two positions would be 150 meters minus 30 meters. So overall, our displacement is 120 meters. Now that we know our displacement, we can plug it into our average velocity formula. Average velocity is equal to 120 meters divided by 3 seconds. So our average velocity here is 40 meters per second. Notice how the question asked for the magnitude of the average velocity, which means we only have to put the size, the 40 meters per second. No direction necessary. If you have any questions, comments, or concerns, please feel free to ask me during class or after school.